scientists, welcome back. Or should I say physicists? Because now that you are starting to think about how things work, you are also becoming a physicist. So I'm going to introduce you to a song and a poem that can help you remember some of those key physics words that we talked about. Then I'm going to introduce you to our challenge this week. So I'm so excited. It's going to be a good one. By the way, those light shows I saw were phenomenal. You guys are amazing, so creative, so intelligent. Oh, I just loved every second of it. So let's get started. So I brought in a friend of mine to help us do our It's All About Motion poem, because this poem has the movements that are going to help us remember those keywords. So Dr. Monica and I are going to do the motions, and then you guys are going to mirror them back to us. Or actually, Dr. Monica, why don't I do the motions and then you mirror it back to me, and you can do it with the kiddos. Does that sound good? Sounds great. Excellent. All right, let's get started. So, Dr. Monica, you're going to need two hands. You're going to take your hands like this for motion. And it goes like this. Motion is created. Your turn. Motion is created when I move place to place. When I move place to place. Like a spaceship flying high and fast. Like a spaceship flying high and fast into outer space. Into outer space. Pushes and pulls are forces. Pushes and pulls are forces that need energy to work. That need energy to work. I need energy to move in gym. I need energy to move in gym. Or even to lift my fork. Or even to lift my fork. Why isn't there any food on this? Because it's not time to eat. We can eat afterwards. Mac and cheese? Yes, mac and cheese. And ice cream? Depends how well you do. We'll see. Circular, straight, and zigzag. Circular, straight, and zigzag are paths an object can take. Are paths an object can take. Friction causes things to slow. Friction, getting real frictiony, causes things to slow. And then a path can break. And then a path can break. Motion is important. Gotta do the motion sign. Motion is important. We use it all the time. We use it all the time. Your eyes and lungs, your eyes and lungs are moving while you read this little rhyme. Are moving while you read this little rhyme. Yay! Now is it time for macaroni and cheese and ice cream? Almost. I have a few more things I need to do first. Okay, well, wash your hands. I will. Now let's try the whole thing together. Motion is created when I move place to place, like a spaceship flying high and fast into outer space. Push and pull are forces that need energy to work. I need energy to move in gym or even to lift my fork. Circular, straight, and zigzag are paths an object can take. Friction causes things to slow, and then a path can break. Motion is important. We use it all the time. Your eyes and lungs are moving while you read this little rhyme. Nice job. And the next thing we're gonna do is a sing-along. So the poem can help you remember those keywords like friction and motion and circular and zigzag, but the song can also help you remember those if your brain works that way. So I'm gonna sing the song first, and then I'll have Dr. Monica sing it with me, and then I'll introduce you guys to our challenge for the week. Okay, so it goes to the tune of Mary had a little lamb, little lamb, little lamb. But instead of it being about Mary and lambs, it's about motion. And it goes like this. Motion happens every day when we work, when we play. Push and pull are forces used to make an object move. Motion happens every day when we work, when we play. Energy is what we use to make an object move. Now, Dr. Monica, are you ready? Okay, let's do it. Motion happens every day when we work, when we play. Push and pull are forces used to make an object move. Motion happens every day when we work, when we play. Energy is what we use to make an object move. Bravo! Very nice, Dr. Monica. Very, very nice. And you guys could practice that song at home too. It's a fun one. Great way to remember those key words. Okay, now let's talk about your challenge this week. So, because we're talking about motion and forces and pushes and pulls and friction, our challenge this week, if you choose to accept, is to use the engineering design process to build a vehicle that can demonstrate force and motion. So we're going to be following this objective. I can use what I know about force and motion to design a, and here's the key word, moving vehicle. Anyone can design a vehicle, but your challenge is to make it move. So here are your criteria. Your vehicle must be able to move because of a push or a pull. Now that push or pull could be with your hand, it could be with air, that is up to you. You are the physicist, you are the engineer here. Your vehicle must demonstrate different speeds. So whether you're pushing soft and then pushing hard, your vehicle must be able to go a few separate speeds to meet our challenge. You must be able to explain why your vehicle moves and then stops. So tell us the physics behind what's happening and what constraints do you have. You may only use the materials you have around your house with your parents' permission. You are not, and this is not, you are not limited to doing a rolling vehicle. Flying and floating vehicles are also a great option. So on my board here, I drew a car with wheels and axles, but I also drew a glider and I drew a sailboat in case your brain wants to go kind of down those paths as well. Those are also vehicles. And you can share your vehicle with your class next week. So I'll talk to your teachers, whether it's on Facebook with a photograph or a video or on your Zoom session. We'll figure out a good way for you guys to share your thinking. I'm excited. So moving on to imagining. So you guys are gonna brainstorm your possible solutions. It could be a rolling vehicle. So I chose personally to do a rolling vehicle, but there are so many kinds. I could do a semi-truck, I could do a Corolla, I could do a Jeep, I could do a bicycle. There's lots and lots of vehicles that roll using wheels. I could do a floating vehicle. a flying vehicle, I'm going to brainstorm my solutions and then circle the one that I want to try first. That doesn't mean I can't go back and try those later, because I can. I'm an engineer. Then I'm going to draw and label my design. I've seen lots of great drawings. Something we can work on is that labeling piece, because when you make a really good plan, it is so easy to go back and follow because you've already thought through those potential problems that could be coming. I list my materials I need, and then I create it. I follow my plan and I build my vehicle and I test it. I make sure that it can move. I make sure that it can go separate speeds, and I make sure that I understand what's happening. I decide, did my vehicle work? Yes or no? How can I improve it? I'm gonna go back and make some improvements. So this is just the very beginning of my prototype. These are my favorite, these little Rockin' protein drinks. So what I did is I just used a stick, and I happen to have these wheels laying around. You don't have to have wheels. You can have anything circular. It could be a lid. It could be, there's tons and tons of kinds of lids. It could be a cracker. It could be anything that's circular that you can use for a wheel and do something to connect it to an axle. So I just put holes in my bottle. If you're choosing to put holes in an item like plastic, please make sure you're using adult help. I don't want anybody to get hurt. So right now my vehicle does move, but it's not balanced well yet. So it rolls, but one of my wheels doesn't really, it doesn't turn very well. So I need to make some improvements so that my vehicle really moves. Now, this could be a challenge just for you. Could also be a challenge for you and maybe your mom, or maybe your younger sister or your brother. And you guys can all make vehicles and then you can race them. That would be super fun. So now you know a poem, you know a song, and you have a challenge for this week. I am super excited to see what you guys come up with. Physicist, you're amazing. And yeah, stay curious.